In this video, we are going to see about the computation of transmission line parameters using MATLAB. Transmission lines have four electrical parameters such as resistance, inductance, capacitance, and conductance. The inductance and capacitance are due to the effect of magnetic and electric field around the conductor. The transmission line is represented by an equivalent circuit model with the appropriate circuit parameters on each phase basics. First, see about the general formula. The formula for computing the inductance per phase in millihenry per kilometer of the transmission line is given by, say, inductance L is equal to 0.2 into natural log of dm by ds in millihenry per kilometer. Here, dm is nothing but geometric mean distance, so ds is nothing but geometric mean radius. Similarly, we have to calculate the capacitance. The formula for calculating the capacitance per phase in microfarad per kilometer is given as C is equal to 0.56 divided by natural log of dm divided by ds. Next, we have to calculate the Gmr of equivalent conductor of two subconductor. So that is nothing but square root of ds into d. So where d is the bundle spacing. Next, GMD of equivalent conductor of two conductors bundling. We have to calculate the value of ds, that is equal to 3 root of DSA, DSB and DSC, where DSA, DSB and DSC are GMR of each phase group and is given as DSA, DSB, DSC, the distance between the A conductor and the B and C. In the same manner, we have to represent for the three phase group. Okay, the next equivalent GMD per phase, GMD is equal to calculate for A, B, C, all the three conductors, power 1 by 3. So here the DAB, DBC and DC are the GMD between each phase group and is given as DAB is equal to the distance between the A and B conductor respectively, power 1 by 4. Similarly, for the distance between the BC and CA are represented as here. Next, see about the example how to calculate the inductance and capacitance per phase per kilometer of the given configuration using MATLAB software. So this is a given configuration. It consists of a 3-phase double circuit line. So this is a one circuit. The one circuit consists of conductor A, B, C. Similarly, the another circuit consists of conductor A dash, B dash and C dash. So here the configuration represented for the distance between the two conductors for top, middle and bottom conductors. Similarly, the height between the top to middle and middle to bottom conductors. Here, the distance between the conductor A1 and C2. So consider here A, B, C or A1, B1, C1. So A dash, B dash, C dash is nothing but A2, B2, C2. Open the MATLAB. So either maybe it is an offline or online. We have to open the MATLAB editor. So in this MATLAB editor, we have to write the program. So what we have discussed in this problem, we have to represent everything. Already we have seen that formulas. So the first command is, so clear all is represented about the all the variables already stored in the MATLAB is clear. CLC is nothing but clear scheme. We have to assign the variable or small is or is nothing but the actual given conductor radius, that is 0.9 centimeter. Next, we have to assign the variable dA1C2 is nothing but the distance, that is nothing but A1 to C2. Already shown that configuration, So from that we have to represent the spacing between the topmost conductor A1 and C2, that is nothing but 6 meters. Similarly, the spacing between the topmost, actually middle conductor, this one is actually spacing between the bottom. So DC1 and A2. So 6 meters, 7 meters, 6 meters like that. Next we have to give the variables DTM is nothing but the distance between top and middle conductor, 3 meter. Next variable DMB represent the distance between the middle and bottom conductor, that is 3 meter. Next assign the variable capital R is nothing but radius of fictitious conductor, that is 0.7788 into the actual conductor radius. Next we have to calculate the distance between the A1 and A2. So dA1 A2, that is the square root of dA1 C2 squared plus dTm plus dMp whole square. So next we have to take the calculation for distance between the C1 and C2. So dC1 and dC2 is equal to actual value of dA1, both are equal. dA12 is equal to dC1 C2. Next we have to calculate the Gmr of conductor ABC. So this is the calculation for Gmr, geometric mean radius of A conductor, that is square root of R into D distance between A1 A2. Similarly Gmr B conductor, square root of R into D B1 B2. Similarly Gmr of C third conductor phase C conductor, square root of R into DC1 C2. Next we have to calculate the geometric mean distance. We have to multiply all the GMR A, B, C power 1 by 3. We can get the value of geometric mean distance ds. Next we have to calculate the distance between the A1 and B1. Similarly for A1 and B2. That is square root of dTm square plus dB1 B2 minus dA1 C2 divided by 2 whole power square. So in the same way we have to calculate the distance between A1 to B2. Next we have to calculate the GMD between base A and B. So GMR of AB is nothing but square root of distance between A1 B1 into distance between A1 B2. Similarly GMR BC is equal to REB, both are equal. Next GMR AC is equal to square root of distance between A1 C2 plus DTM plus DMP. Next we have to calculate the equivalent spacing. D equivalent is equal to, we have to multiply all the GMR A, B, BC and AC conductor power 1 by 3. Next we have to calculate the value of inductance per phase per kilometer. We have to take 2 into e power minus 7 into log of D equivalent into ds. Next we have to calculate the value of capacitance. In that we need to calculate the distance between DSEA, DSEB and DSCC. That is DSEA is square root of R into distance between A1 A2. Similarly we have to multiply square root of multiply the value of distance between B1 B2 into R. Similarly for CC, distance between C1 C2 into R. We have to calculate the geometric mean distance. After that we have to apply or assign the values DSC and D equivalent in this formula. Already we have seen what is the formula for the capacitance calculation. We have to apply that. After completing this program, I am going to the editor menu and clicks run. Already I have saved the file computation of line parameters. File name is computation of line parameters. You can see that what are the variables declared here. All the variables, the values will be stored in the workspace. So this is the actual net result what we have need to calculate, that is a calculated value inductance and capacitance. This is the ultimate aim to calculate the inductance and capacitance of the transmission line. So these are the various variables used for calculating the value of inductance and capacitance. So those values are saved in workspace. Okay.